If we look around the apartment and look at the things we use daily, we will find that most of them have a expiration date, whether it was food, or drink, or even personal products. They all have a time and a date, and if they don't do the job they were doing during the expiration date, and it is the time that differs from one product to the other, depending on the many of them, the nature of the product, the way it is stored, the place it is stored in, and many others. Although there are almost no products that do not have a validity, most of us do not care about the validity date, except for the products that enter our mouths only, whether food or medicine. So that, God forbid, there is no poisoning or anything. And here is a question that arises: does the poison have a validity date like the rest of the products? And if we assume that it has, if this validity is over, the poison inside weakens and disappears. Or does the poison become stronger than before? Before we answer our question, we need to know first: which poison exactly are you asking about when we come to know the word poison, either by eating, drinking, or by excretion, or by touching, and this element can be artificial or natural. Based on this wide and complex distortion, we can't talk about poison as a single substance and limit it to the poison of a certain drug. It's much bigger than that. If we go back in time, did humans discover hundreds of types of toxins, and with each passing time, humans discover new types as well, and because of this, and as a result of this great diversity, the Greek doctor Paracelsus, who lived in the early 16th century, dedicated his entire life to studying toxins. And he came to us in the end with the famous saying that goes, "Everything around us is a toxic substance, the vermin alone is what makes them non-toxic." And this saying, despite its oddity, however, science has proven that it is 100% true. If we look at the most essential substance we can't live without, which is water, we'll find that this applies to water as well. Some people can get water poisoning if they drink a large amount of it, more than their body needs. And this is what we're all looking for. And that's why a whole branch of science has emerged to study toxins, called toxicology. This science, in order to facilitate the spread of toxins, has been distributed to different groups. We'll find that there's a division of toxins that are either medicinal, nutritional, or neurotic, and another division depends on the physical shape of the substance, and there are 4 types of these: either liquid, solid, gas, or steam. And the third division is the division of toxins based on their origin. Is it plant or animal, or what exactly? And if you imagine that the kingdom of animals alone has more than 220,000 types of toxins, and of course the best types of poison used in the world today are the poison of the snakes, spiders, and scorpions. And by the way, these are not all the types of poison. There are many other very fascinating types, and the purpose of this whole video is to introduce you to the word poison, a very wide word. So to answer the question of the episode, we will define the type of poison to know how to answer. So let's start with the most famous type of poison, which is the poison of the snakes. There is a nice experiment done by an Egyptian YouTuber that included 3 of the most dangerous effects of the Egyptian deserts: the effect of the tarasha, the effect of the tarantula, and the cobra. He took from each of them and became the adder of the poison. Then he sucked blood from his body and mixed it in a tube with the poison. With the naked eye and without any microscope, he noticed that although they were all poisoned, each of them had a different effect on the blood. The small one, for example, made the blood run, and the big one didn't affect the blood at all. And that means that even the one type of the animal that is produced differs from one type to another. Each one of them contains hundreds of protein compounds and different enzymes, and what's more amazing is that maybe one creature can carry a mixture of more than one toxin at the same time. For example, Tarashia contains 13 different toxins. The idea is that all toxins extracted from animals and plants are called organotoxins, and this type of toxins takes time to be analyzed. But since these toxins consist of more than one compound, each compound has a different shelf life, and often it is a very long shelf life. So, for example, if you have 13 toxins in Tertiea, if one or two of the 13 substances in the Tertiea poison are analyzed, we will still have 11 other substances that would be worth it if we gave them to anyone. But even these 11, like them or others, will still be less than one after the other when their effectiveness is exhausted. This means that the poison is excluded from plants and animals, which are the two main sources of organic toxins. If its effectiveness is exhausted, its effectiveness will be less. And here we move to the second half of the question: is this the case with all toxins or only with organoids? What makes organoids to be dissolved over time is that the compounds inside it contain carbon and hydrogen atoms, which usually have weak bonds and are easy to break, and therefore these compounds are dissolved. But there are other compounds that do not contain carbon or hydrogen together. It may contain carbon but not hydrogen, and in this case it is called non-organic toxins. For example, if we take bullets and bullets, since they are highly toxic, we will find that in their non-organic form, they are not analyzed. But does this mean that they are not healthy? The answer is yes and no. Bullets and bullets are naturally present in the Earth's crust, and they are not analyzed in the way they are known. But they have a period called half-life, which is the time that the element takes to digest half of its quantity, meaning that it won't be digested and its toxicity or activity won't decrease, but its quantity itself will decrease, and this time can reach tens of years. And you have, for example, one of the types of bullets which is 210 bullets. Its half-life can reach more than 22 years, meaning that if you took 10 grams of it and put it in a water tank, and after 22 years of looking at them you will find that they are 5 grams. But 1 gram will still have the same normal characteristics and its toxicity will not decrease. But be careful, we are talking about toxins in the non-organic state. Pesticides and similar toxins, if in an organic state, will have a normal solubility principle and their toxicity will decrease with time. There are toxins that have a shelf life, but when this shelf life ends, the effect of the toxins is not reduced. This is the exact opposite result. And this is what we see in some types of manufactured toxins. If we take, for example, insecticides for plants as an example, we will find that they are toxins that are made to eliminate the harmful effects of agricultural pesticides. However, the companies that manufacture pesticides put a shelf life on the toxin's shelf life so that it can be used again, to give it back to him before use. The American Society of Medicine warned against using insecticides after 2 years of opening the father. It turned out that the insecticides of plants, if used after the end of fertility, can cause the plant to become poisoned. And of course, if this plant eats these pesticides, will harm the health of the person who eats it. So there are types of toxins when its fertility ends, its effect increases, not decreases. And this does not only happen with pesticides. This is also found in some human drugs. And don't be surprised, there are drugs that we treat with, that are very normal toxins. And some of them, when the efficacy ends, can react or be analyzed and turn into toxic compounds that harm the liver or kidneys. And these compounds, of course, we can't define them because they differ in the difference of the drug itself. And that's why, at the end of the episode, we must understand that toxins are not the same. There are toxins that decrease when they're used up, and other toxins that increase when they're used up. And no matter how long a toxin is used up, it doesn't affect it. That's it.